Alright, what up fam? Here we go for this review packet. Sorry for this being late. Let's just get through it. So, first of all, tiny itsy bitsy error on this guy. There should be a pi in front of this. I don't really know what happened on the printing of this guy, but should be a pi right there. Pi r squared is the area of that sector times theta over 360. Alright, first problem here. The center of the circle, nice and easy. It's just the letter A. It's that middle part of the circle. I don't really think there's too much there. There are two different radii here. Radii are line segments. It's a little part there, so we can write AC. There's one right there. Boom, connected. Likewise, the other one is going to be AB. And please note you could write that in the opposite direction. BA and CA would also be acceptable. Your diameter is the length all the way across. So we got BC. Chords, there are two chords here. The chord BC, the diameter, is a chord. Likewise, EF with a line segment over it is going to be a chord, that little part right there. And again, you could write this backwards, FE. A secant is a line that goes all the way through the circle. So EF is the most obvious one, so it goes all the way through. Please note, EF is a chord and it's a secant. Likewise, BC with a line over it would also be a secant if we decided to extend those and write arrows at the end of them. A tangent is a line that barely touches, so in this case line L is a tangent line that barely touches the edge of the circle there. Please note, as a reminder, these create right angles with radii or diameters. And the point of tangency where it touches just that letter C. Really not too bad. Gotta have those definitions down pat, memorized. Not really much else to say. Concentric circles are going to be two circles that are on the inside of each other, or one that's on the inside of another. Internally tangent circles, there's a circle and a circle that barely taps on the edge out there. Boom. So there's another one. And externally tangent circles are circles where they barely tap, one on the outside. Boom. Not that big a deal. There's really not much to it. Going on to the next page. Right here, draw an example of two circles who share a common tangent. So two circles sharing a common tangent. I'm going to draw this version, one that's on the smaller edge out here where kaboom, they barely tap. That tangent line is common because it barely taps, and there'd be another one out here that barely taps. There are a few other ways of writing these, but I think that's probably the easiest way to do it. This next one, lines that appear to be tangent are tangent. So this guy right here is a tangent line that barely touches. Tangent lines create right angles with radii. That's what this hint is trying to tell you. So that 3.5, that means that this is also 3.5, which means the entire length here from here to here is 7. And as we can see, we get a nice little right triangle. So 7 squared plus x squared equals 25 squared. Solving for x is really not that big a deal. Just subtract 7 squared on both sides. 25 squared is the same thing as 625. Subtract the 7 squared, that's going to be minus 49. Take the square root of both sides, and if you take the square root of both sides of this equation, you're going to end up getting exactly 24. Easy enough. So here we go, solve for x. So we have 7x plus 20 has to be equal to 4x plus 8. That is a rule of thumb. If two tangent lines meet on the outside, these two must be the same exact length. So we just set these equal to each other and solve. If we subtract 4x over here, we'll end up getting 3x. Subtract 20 over here, and we'll get negative 12. So x must be negative 4. However, this is a trick question, and I put this on here in particular on this guy. The reason why this is a trick question is x can't actually be negative 4. If it was negative 4, if you notice, 4 multiplied by negative 4 plus 8, that's going to be negative 8. You can have a length of negative 8, so really the answer is no solution. Please note, the actual quiz will have solutions, but I did think it was interesting on this one to put a question that had no correct answer, because questions like that can show up on the SAT and ACT. Next question here, draw a circle that circumscribes an equilateral triangle. I give you a hint to what that means. Here's our circle, and we have an equilateral triangle on the inside of it. Equilateral triangles, remember, they all have 60s, kind of like that hint, and all these lengths are the same. Because those lengths are the same, the arcs must also be the same, because equivalent congruent chords create congruent arcs. And if those are all the same, we have basically 3 different arc lengths there. If I wanted to call this x degrees, all of these degrees must add up to the entire circle, 360 degrees. So 3x is the same thing as 360, or x is 120 degrees. Easy enough. Really not that much to it. Let's go to the next page. Find the perimeter of this triangle. So perimeter of the triangle is this length out here. Same exact idea as the previous question. Equivalent arcs create equivalent chords. Please note, that does not mean this one is the same. Only the ones that are marked the same are the same. Because the ones that are marked the same are the same, we have 7x equals 2x plus 5. Therefore, 5x equals 5. Divide both sides. X equals 1. And if x is equal to 1, we can now plug x in here, and we get 7 is this length. Likewise, 7 is this length. And if we plug 1 into here, 3 multiplied by 1 is 3, minus 2 is 1. Perimeter is all three added together. 7 plus 1 is 15. Boom. Easy enough. Next one. Draw circle 0 with points around it. Boom, boom, boom. Here's 0, the center of our circle. And it has points around it A, B, C, D, E in that order, such that AC and BD are diameters. So A can be literally anywhere. Arbitrarily, I'm choosing there for letter A. It could be actually anywhere. When I say in order, you can either go to the left, counterclockwise, or to the right, clockwise. Arbitrarily, I'm choosing this guy right here to be letter B. There's absolutely no reason I picked that point. I could have picked anywhere else in the entire circle. But the next coordinate is important. It must be directly apart from A. There's letter C. Why does it be directly apart? Because AC is a diameter. So AC is our diameter of this circle. Likewise, BD is a diameter of the circle. Then it has this other letter E somewhere else. So A, B, C, D, E must be somewhere over here. I am totally arbitrarily picking right there to be the letter E. There is no reason for this at all other than it has to be between A and D. Then it says the measure of arc AE is 80 degrees. So this guy right here is 80 degrees. That means there's also this is 80 degrees. It says measure of AOB. AOB is 20, which makes this 20 degrees, which makes this 20 degrees. This guy over here must also be 20 degrees. That's our vertical angles rule. 20 and 80, and this guy must add up to 180 degrees. If they add up to 180 degrees, if 20 plus 80 plus this x equals 180 degrees, x must be 80. Subtracting 100 on both sides there. That means this guy is 80. Similar logic is going to tell us that this side over here must be 160 degrees. So 20, 80, 160. Doing the rest of this is a fairly easy process. Measure of AOE. AOE, well, that's 80. Measure of arc AB, 20 degrees. Note that all these with an M in front, that means measure. It's going to be a way of writing the degrees right there. The measure of BC, here to here, we've already marked that as 160 degrees. And BDE, BDE, you cannot go this way because that crosses over E in the wrong order. It must be this way. BDE, 160 plus 20 plus 80, 260 degrees. Easy enough. The length of BED. Note there's no M in front. When there's no M in front, what that's trying to say is the actual physical length of BED. It's this length out here. The length of any arc from that front page is going to be equal to BED, must be equivalent to 2 multiplied by pi multiplied by the radius multiplied by theta over 360. Because it says AC is 24, AC is a diameter, that directly implies that the radius is 12, half of that length, half a diameter. So 2 times pi times 12 times theta over 360. Oh, what's theta though? Theta in this problem is equal to all the way from, oh my gosh, it's BED. BED. These guys, all added together, that's going to be 2 times pi times 12 times 180 over 360. It's that entire angles value. This reduces 2 times pi times 12 times 1/2. And again, you could use this on a calculator. You don't have to do this by hand. 2 over 2 is 1, and you simply get 12 pi as your answer. If you needed to approximate this on a calculator, you could. Unfortunately, I don't have a calculator with me, so I can't do it. But if you do, make sure you plug it in using the exact value of pi, using that pi button on your calculator. But you know what? We're just going to leave this as 12 pi. So this is letter A. Letter B here, it says area of the sector subtended by the points A and B centered at O. So subtended means created by. So we're finding this area right there. Area of a sector is going to be equal to pi times r squared times theta over 360. The area is therefore going to be pi multiplied by 12 squared times 20 over 360. That means the area is going to be equal to pi times 144. Again, feel free to use a calculator. Reducing this guy, times 1 over 18. And it turns out that 144 divided by 18 is exactly 8. So the area is going to be 8 pi. And again, you could approximate this on a calculator. I have no idea what that is, though, so let's just leave it as 8 pi. Turning it over to the next page. Very last side. Key here is remembering that this length right here is a radius. So the radius of this circle is 18. 7 plus 11. That means that this guy here must be 18, and this guy here must also be 18. Now, you do have to now remember that it wants this entire length mn. So you need to figure out what this whole length is. But if you figure out what this is, the x value here, it creates a nice little right triangle such that x squared plus 7 squared equals 18 squared. And therefore x squared equals 18 squared, I'm fairly certain is 324, but if I'm wrong, well, I guess you guys can tell me on a calculator. 324 minus 29. So x must therefore be equal to, gotta do some math here. What do you have? 274 is the minus 50, minus 49 must be 275, square rooted. And we need 2 of those. So 2x, which is the length of mn, must be equal to 2 times the square root of 275. I have no idea what this is, the nearest 1,000th. I do remember, though, let's see if I can remember off the top of my head from class. Maybe, you know what, I'm just going to type this into a good friend on my computer here, and I'm going to figure out what this exact value is. So, sorry about this for a second. I don't have a calculator with me, but it does say to the nearest 1,000th. Let's make sure we do this right. If you type in 2 times the square root of 275, rounded correctly to the nearest 1,000th, that's 3 decimal places. That means 3 decimal, by the way, because it's to the 1,000. If you do it to the decimal, you'll end up getting 33.166. Easy enough. Complete the square to find the center of the radius. Step 1, move everything to that left-hand side in the correct order. So we got x squared plus 6x. And because we have x squared plus 6x, we're going to start putting this in parentheses and leaving a blank spot for ourselves. Plus, move the y squared over. Y squared minus 4y. It stays negative because it's on that side. Plus a blank spot equals, add the 36 to the other side. So now we have to go off to the side to actually complete the square. So going off to the side to complete the square, we're going to go ahead and say 6x and negative 4y. We're going to take away the x, take away the y, divide by 2 and put a star, divide by 2 and put a star. We're going to use that starred value later, and square. We're going to put these guys in those blanks. Nope. Don't forget to add it to the other side as well. The whole point of putting these stars here, the whole point of doing this problem is to rewrite this guy as a perfect square. Rewrite this guy as a perfect square. Again, that 3 comes from the star, that negative 2 comes from the star. You could always double check this if you really wanted to. That x plus 3 squared means x plus 3 times x plus 3. If you FOILed this out, you would get x squared plus 3x plus 3x plus 9, which is this guy right here. Easy enough. Adding these together, 36 plus 9 plus 4 is 49. Therefore, the center of my circle is at negative 3, 2. It is the opposite of these signs, what makes them equal to 0. And therefore the radius is also the square root of this guy, which is just 7. Easy enough. If you do want to do this extra credit with me at a different time, you can. There actually is a nice, neat little formula for segment. If you want to go through this proof with me later, you definitely can. I'm not going to go through it right now, but I will write down the area of the segment formula for those who do want to memorize it for those SATs, ACTs, etc. You're finding the area of the sector of the circle and subtracting the area of the triangle. So you're finding like the entire area of this sector here, and you're subtracting the area of this triangle right there. So the area of that triangle is going to be subtracted, and you're finding this little area up there in the end. The area of the segment has a consistent formula. It's always going to be the radius squared multiplied by pi times theta divided by 360 minus, if you notice, it's like the area of the sector right there, r squared times the sine of theta, and then you actually divide this by 2. Again, if you want to go through this proof with me later, feel free, but this is actually the formula for this problem. I forgot the exact answer, but it's 0.5 something. If you want to find the exact value of this guy, it does end up being that. Nice, easy little video, guys. Have a great time taking this quiz. Good luck. And then good luck on the benchmarks on Thursday. Have a good one.